Picking up where we left off on problem number 1 from section 5E, part C, we found the standard deviation of the residual errors. Is it going to be in units of the same units as Y? In this case, tar is Y, so the units are milligrams. And so standard deviation of the residual errors is 1.298 milligrams of tar. All right. What else? And to interpret that, I'm going to look back on page 251 of the textbook. In the middle of the page, we have interpreting the standard deviation of the residual errors. The standard deviation tells us two important things. How far typical points are from the regression line on average. So it's measuring the distance, the vertical distance between the regression line and the data point. Think of it as a measure of the average distance from the line. If there is a correlation, we can use the regression lines as a formula to make predictions. So the standard deviation gives us a measure of the average prediction error. So if we use the regression line to make a prediction, then the standard deviation of the residual tells us how far off the prediction might be on average. So 1, this is the average distance that the points are from the regression line, and 2, the average amount of prediction error when we use the prediction line to make a prediction. So I'm going to state those now in my Word document. So in my Word document, I'll say SE is 1.298 milligrams of tar. And what that means is the points in the scatter plot are 1.298 milligrams of tar from the regression line on average. In the second interpretation, the bullet point number 2 from that last section. So if is kind of applied to if we actually use that as a prediction. So if we use a nicotine value in the scope of the X values and regression line to predict the amount of tar cigarette tar a cigarette has, our prediction could have an average error of 1.298 milligrams. So when I predict on average, I'm going to be off by the on average I'll be off by 1.298 milligrams. All right, so that's all of problem number 1 for 5E. In the next video, I'm going to do 5F, problem number 1, which continues with the same data. Before I do that, I want to recap what this regression analysis from Excel is giving us. I've highlighted the things that we are using. The multiple R was the correlation coefficient, that's in green. And then the R squared is just R squared. Standard deviation of residual errors that we learned today at 5E. This intercept refers to the B1 from our slope-intercept equation. And this number responds to the coefficient here, the B naught starting value. I'm sorry, I switched that up. Yeah, these are actually colored the wrong way. My mistake. I need to fix that. Oh dear. Yikes, I wish I had noticed that before. Okay, so the intercept, though, of course, is the intercept right here, and then this second number is the slope.